Cool. So thank you for having me as a speaker today at NDC Copenhagen. It's nice to be back in person on the stage. And I'm Poornima Nayar. I'll be talking about JSON over HTTP multiple ways. A little bit about myself. I'm a freelance .NET developer, and I live in Berkshire, UK with my husband and 7-year-old daughter. I'm a Microsoft MVP for developer technologies, and I do a lot of work with Umbraco, which is a .NET-based open source CMS. In fact, my day-to-day job is primarily with Umbraco, and I've been an Umbraco MVP for the past 3 years. Non-work me, you already know that I'm a mother. So right now, my husband and kiddo are in Denmark. They are at Legoland while mommy speaks at NDC. And non-work me again, I do a lot of reading. I can read anything, tech books to English novel, that's all good. And I'm also a student of Carnatic music vocals. Carnatic music is a stream of Indian classical music, and I have been a student for the past 5 years on its vocals. And that's my Twitter handle, should you wish to connect with me on Twitter. Talking about JSON over HTTP, it's probably the most popular API pattern out there. Think of an API which you would want to develop. I think as developers, we have this subconscious mentality to go towards JSON and HTTP. It's that popular as a pattern. But when we do that, we invariably, or at least I have done this, been there, done that, give the name REST. Whether REST is JSON over HTTP is an entirely different discussion for another day. But that's not the point that I want to make today. There are other patterns which can help you serve JSON over HTTP, like GraphQL and the newest gRPC, JSON Transcoding. So we'll have a look at all these 3 API patterns and go for a comparison at the end. So any questions, come find me after the talk and we can have a conversation, because the last time I practiced, I was bordering on about 59 minutes with the talk today. Talking about HTTP, HTTP is everywhere, but still a little bit of history. Is the foundation of communication for the World Wide Web. The first revision was in 1996, followed by 1.1 of HTTP in 1997. We've had updates after that to HTTP 1.1, with the latest updates happening in 2014. But right now, we also have HTTP 2 as a published RFC, and that was done in May 2015. We are also looking at HTTP 3, and the first draft of HTTP 3 was published in 2020. It is getting out there, which means that even patterns like gRPC, which came out with official support in .NET with the version 3.0 of .NET Core, gRPC is beginning to have support with HTTP 3 as well. It's a stateless protocol. What HTTP gives us is a very rich toolkit, like request, responses, caching, authentication, and HTTP methods, to the point that when we talk about the various different patterns of APIs serving data over HTTP, it all boils down to how these API patterns use this really nice toolkit which HTTP provides us with. And my talk deals with exactly the same. We'll be talking about requests, responses, and HTTP methods quite a lot today. Talking about JSON, they say that after the first JSON message was sent in 2001, the rest is history. It's an open standard, it's lightweight, it's text-based, and it's language independent, which makes it a really popular choice for developers out there. And the widespread adoption of JavaScript and the popularity which REST gained amongst developers made JSON even more popular, to the point that every programming language out there has a way of parsing and understanding JSON. I'm a .NET developer. I like to talk about .NET packages and what's happening in the .NET realm. And we have Newtonsoft JSON, which is incredibly popular, has been out there for ages. And we also have System Text JSON, which is kind of newer into the realm at the moment. And my focus, all my code today uses System Text JSON. This package is built in as a part of the shared framework for .NET Core 3.0 and later. So if you create say a web API project or anything that needs JSON at the moment, this would be your go-to library at the moment. But you can even have it in previous versions of .NET Core. Newtonsoft JSON still continues to exist. You can have support for that. That's all there. With System Text JSON, it uses runtime reflection to gather metadata. Metadata is the information that the package needs to access things like information on how to access the property getters or the property setters. What about the customizations that you can have to your .NET classes? That is the metadata that it needs. And this metadata is gathered at runtime by default by this package. However, with .NET 6, you can also use source generation to gather the same metadata at compile time. If you are after performance with serialization and deserialization, source generation is the way to go, because I read somewhere that there's about 40% increase in performance when you do it the source generation way, because this happens entirely at compile time. However, the richer feature set is with the runtime reflection way. It has more features. So if you want to have a good comparison of what each pattern supports, go have a look at the MS Docs documentation for this. I have included a link to that in my resource docs at the end of the day. So for my API patterns, I am coming up with a simple to-do list API, which is based on a very simple class, which looks like so. You'll get to see this class more often now. And it's got all the usual suspects like ID, name, complete notes. But trust me, I'm a working mother. I'm a full-time working mother. And no to-do list API can sort out things for me. Everything is in my brain, and I multitask like no one else. But nevertheless, what I expect to see at the end of my API is a JSON object that looks like this. This is the web default of this particular class, because there are certain behavioral differences between default system text JSON and the web defaults. For example, by default, system text JSON uses the .NET casing. So if you have a .NET casing in your class, that is used by default when it serializes, unless and until you choose to customize it. But the web defaults to camel casing. You get minified JSON. There's no change there. However, you can prettify it. And system text JSON by default uses case-sensitive property names for deserialization. Again, for web default, it's case insensitive. So there are certain subtle behavioral changes when it comes to web default and the system text JSON default. And with that, we can move to the first API pattern of the day. That's HTTP API. I'm not going fully REST for the day because I don't want to bring extra complexities in, but we will discuss REST very briefly. The first point is just because you have an HTTP API doesn't make it a REST API, because RESTful APIs are completely governed by these 6 constraints, which are known as the fielding constraints: client server, stateless, cacheability, uniform interface, layered system, and code on demand. But when an HTTP API actually, it kind of conforms to most of this, I think the key breaking factor there is HATIOS, which is quite intimidating as a term, and that's hypermedia as the engine of application state. This is what really makes your HTTP API a RESTful API. Nevertheless, with a good HTTP API, we always think in terms of resources. A resource can be anything which can have a representation. It can be a web page, it can be a person, it can be a car. Anything that can have a representation, a meaningful representation, is a resource. You think about resources. A resource has a uniform resource identifier, which is always unique. And in our case, when we are talking about APIs, it's URLs. And a resource always has a representation, that is the data, plus the metadata that makes up the resource representation. Again, I have left out the hypermedia controls for simplicity's sake today. And what we have with the HTTP API pattern is a very seamless integration of the HTTP toolkit to how the API works. You begin with a resource, and each resource has a URL. In our example, something like /to-do-items. And then you issue the various HTTP verbs with or without the request body, whichever is appropriate for the HTTP verb which you are using. And then you try and respond back with a meaningful status code. That status code conveys a lot of meaning to your clients, and that should be appropriate as well. So here is a rough mapping of what the HTTP verbs are and the status codes could be. For example, if you want to read some information, you would do get. If you want to create a new to-do item, you would do a post. For updates, you have both put and patch. So these are 2 HTTP verbs, and they are slightly different in the sense that With HTTP put, it replaces a resource in its entirety. So which means that the request body that I give is a resource in itself. However, with patch, it is incremental updates that you're doing. Probably you just want to update the due date. Probably you just want to, say, update the nodes for a particular to-do item. So the request body is quite different when it comes to patch as well. You would have, say, this is the to-do item, the ID of the to-do item which I want to update. Here is the field I want to update, and here is the value I want to update that field with. So it's a very different request body as well. And for deleting a to-do item, you would do an HTTP delete. The status code is important here because that conveys a lot of meaning and a lot of sense to the consuming clients. Now, talking about building the API, I've got a lot of code in my slides, but there is a GitHub repo which I will share at the end, which has got all the 3 API patterns with all the HTTP verbs in place for you. I'm using the Web API framework here. Again, I start off with the class and I have my API controller. But Web API is not the only way you can serve JSON over HTTP in the .NET world itself when it comes to an HTTP API. If you're not thinking about resources, but you just want to send JSON over HTTP, there is also something called route to code, something which I have not really investigated, but I see a full-fledged ASP.NET community stand up on the .NET YouTube channel, so it's very well worth checking it out as well. Back to our Web API controller, it inherits from controller base. I've got the route attribute, which controls my route. So in this case, I've got the API, that's a prefix, and the controller name, which acts as the route template. And the API controller attribute here gives me access to a lot of goodies like binding, the problem details factory, the routing, etc. A lot of goodies comes alongside with it. And I've got this to-do items repository, which I'm injecting into my controller, which helps me access my SQLite database behind the scenes, and it does all the heavy lifting for me to keep my controller class clean. So to get an item, I start off with an action method, issuing the HTTP GET method, and the ID of the item which I want to read information about comes in as a route parameter. My repository gets to do the heavy lifting for me. And if I have a to-do item corresponding to the ID that comes in, I return that to-do item. If I don't have anything, say if the to-do item doesn't exist, I'm returning a not found, that is 404. This actually returns JSON by default. That's because Web APIs defaults to JSON as the media type. You can have XML as well, but the default is JSON. And what I get from my API method is a 200 status code with a response body and some response headers. You can add more information to the response headers, but I've kept it plain and simple for the day. Talking about creating an item, again, we have an action method, and we issue an HTTP post. There is a to-do item which comes in as a part of the request body. Let us come back to this a bit later on when we talk about problem details, but we have the repository doing the heavy lifting for me. And because this is a HTTP post, we have the request body that comes in, and that maps to the object that I have got here. This binding is something that the API controller attribute gives me as well. And what I get back as the response is a 201 status code. It gives me some JSON. It returns the object that's been newly created. But in addition, it also adds a header to the response headers. Yes? Sorry, I didn't get you on that one. Oh, that needs to come in from a client. So it can be any app of your choice, say a mobile app or another web app, or even a JavaScript-driven app. Any client app you can think of can send some data into this API endpoint. Does that help? Yes, I'm coming to that in a minute. So to answer the question, so this is the response that I get back. And that's the JSON response. That is the object that's been newly created. There's the 201 status code. And that's the header in the location header, in the response headers, which tells me what is the URL of the newly created to-do item. So this is what is ideally expected of your HTTP post method. Now, I have the API with HTTP put and delete in place as well. I'll give you the GitHub repo, which you can have a look at later on. Now, we are talking about computers and communication, and everything is not always happy in that world. Of course, we do have the status codes which can help your client gather information on what went wrong. But sometimes that status code itself cannot really be very friendly. And I think many of us have done this, at least I've done this, that is coming up with your own friendly error responses. However, there is a better way to do that. That is with the problem details object. So this is a way to respond with a friendlier error message. And this was proposed as a standard in March 2016 with a media type application problem JSON. It's a JSON object, and it looks something like this. So this is kind of a standard at the moment, and you can use this with your web API controllers to return error responses. So talking about some of the fields, we have the type, which actually tells you in greater detail what actually went wrong, what is happening with this error response, why did you get that in first place, and that's typically a URL. The title is a summary, a short summary of what your error message is all about, and type and title are kind of mandatory for your problem details object. The detail is all about detailed information about the error. It's not debugging information. We are talking about friendly error messaging here in greater detail. An instance is a URL again, a URL at which you can replicate the issue or a URL at which things went wrong. And the balance and accounts that you see here is additional information. So if you want, you can actually extend the problem details object with your own information as well. This is an example which I took off the problem details object RFC itself, and sorry, I haven't actually added the credits here, but you can extend it if you need it to be. Support in the .NET realm, the API controller enables problem details for error status codes. So if you have a 400 error or if you have a validation error for that instance, by default, it gives you the problem details payload. The API controller attribute that you adorn your controller class with takes care of that for you. However, if you want to do exception handling with problem details payload, you need to have a middleware in place, which is this middleware. There are some really good blog posts about it. Again, the links have been added to my resources. I will share that with you. It's a really nice way of sharing friendly error messages with the clients. Now, the breaking factor between HTTP and REST API, Hatios hypermedia as the engine of application state. It's very intimidating as a term, and I think it takes some time to wrap your head around it. It's so intimidating that the last time I spoke about Hatios as REST Nirvana, this was the expression on Leila Porter's face. It's intimidating. The idea is that application state, which is stored on the client, the server needs a way to manipulate it. And that manipulation is done through hypermedia controls, which the server sends you in your API response. So if you look at your response, it could have certain hypermedia controls like this, which caters in for, you have got a resource now, what more can you do about it? That connectivity is what Hatios brings you. Now, this is an example which I did for a previous talk, but having said that, with Hatios, there is no standard or a specification at the moment saying that this is the format you can use to serve your hypermedia controls in. Richardson maturity model, it's a great concept which actually defines how RESTful your system is as a RESTful API. At level 0, we have the plain old XML. Level 1, we start thinking about resources. However, we don't use the HTTP verbs in its entirety. We just stick to resources and HTTP post. Level 2 is what we have been talking about today. We make use of request responses, the correct HTTP verbs, and we still have our resources. However, the glory of REST resides in level 3, which is hypermedia controls in your response. And that is when you have a truly RESTful system or a truly RESTful API. The idea is that if you imagine a website with a collection of web pages, You navigate through the links on the web pages. Nothing is hard-coded. That's exactly like how an API, a RESTful API, should function. It should be a website which the clients can just navigate through. And at this point of time, there's no standard as to what format can you use for hypermedia controls in your response, but these formats could help, starting from HAL to JSON API to Hydra. So that was the world of this is not a spec. And from there, we are going to GraphQL, which is actually a specification. Things are laid in black and white for you, which makes it a lot more easier to implement and talk about as well. GraphQL is a very different type of API in the sense, A, it's a specification, B, it is a query language for your API, and that query language is supported by a server-side runtime, which is capable of understanding those queries and executing such queries. Now, GraphQL comes along as one of the cool kids on the block. I'm not going to go into the great history of GraphQL at all today, but it is made for mobile. Think about an API you need for mobile. Probably you should be using GraphQL. But for me, it was one of those API patterns that took time to kind of understand what is going on behind the scenes. What you get with GraphQL is a single smart endpoint that takes in all those queries that the client sends in and builds some data output for you. So immediately, you can get the idea that clients are in control here. Clients specify the shape of the data that they need, and the server responds back with the similar kind of data graph. Now, if you see here, I have my query, which is JSON-ish, and I have some data that's JSON. That's perfectly fine. However, there are two striking things. My data graph is a mirror image of what I have got here. If you have nested items like the to-do items having a category and fetching of the category as well for me, that can all be done in a single query to the endpoint. But the data that I'll get back will be a mirror image of my query. And that's a part of the spec, that the data should be a mirror image of the query. And the second thing is that the order of the fields I have specified here is actually met. So that also matches up. Again, that's another part of the spec. It's a very client-focused, experience-driven API is what you get with GraphQL. And it's unapologetic about it. At the heart of any GraphQL server, what you have is something called a schema. Schema is the strongly typed system of GraphQL. And GraphQL being a specification, there are many implementations of it in various different programming languages. And any implementation of a GraphQL server helps you establish this schema in its own ways and gives you a server-side runtime which can actually understand those queries. So it actually does two different things. A schema is made up of your object types, so that is what you want to gather information about. In our case, the to-do item. There is directives. The definition of directive is it's a way to describe alternate runtime execution. However, I'll speak about it in the next slide where it'll make more sense to you. The third one is the root operation types. So there are three root operation types. The one is a query, that is for reading information. Mutation, which is for changing information. That can be an insert, update, or a delete, but it is immediately followed by a fetch. So if I insert something into the database, say, it fetches that data out for me. That is how a mutation is supposed to work. And a subscription, which stands for pushed updates, so which means that it's actually something which works alongside a successful mutation. Say, for example, if an event succeeds, then you get a pushed update from the server. So it's like a pub-sub way of communication. And the minimum things that you need to have in your GraphQL API is, of course, your object types and the query. Without a query, there cannot be a GraphQL API. Mutation and subscription are not mandatory. But what the main thing to understand here is both GraphQL types and your root operation types, they are GraphQL types. And each GraphQL type is made up of fields, with each field having a name, a type of the field that it returns, as well as resolvers. And resolvers does the heavy lifting of resolving the field to concrete data. So your GraphQL is like an application layer, which can sit on top of a database, a REST API, or even a collection of a set of GraphQL APIs from which it can gather that information. So resolvers or GraphQL in itself doesn't actually concern itself with where the data is stored. So for example, in your object type, my fields could be ID, name, etc. When it comes to queries, it can be like get a particular to-do item, get me a list of to-do items. When it comes to mutation, say insert a new to-do item or mark a field, mark a to-do item is complete, they all can be fields in my types. And with a type, they don't have any meaning as such. It's the fields which bring in meanings to the object types. And with a type, you cannot ask for all the information about a type. You have to be really specific about what you want from an object type. So in such instances, there might be cases where you want a field or you don't want a field. So that, yes, I want it, yes, I don't want it, based upon a condition, that is what directives bring in. So you can alter the execution, saying, I want this, I don't want this, based upon certain conditions, and that's what directives help you with. There are two directives which should be a part of every GraphQL server implementation, that is skip and include. Now, GraphQL is transport layer agnostic, but GraphQL over HTTP is the most common pattern out there because HTTP is everywhere. GraphQL over HTTP is not a standard, a published standard by any means. It's a work in progress thing because many of the implementers have put together some best practices, which is now getting into black and white format with a published, a work in progress standard. So as I said, GraphQL over HTTP is an implementation of GraphQL over HTTP. If you want something that works over WebSockets, you need GraphQL over WebSockets. But let's have a look at some of the main points with GraphQL over HTTP. The first and foremost is that it needs to handle at least it needs to have at least one URL that can handle GraphQL requests for you. The one being /GraphQL, or that's a recommended one. The server must accept post requests, and it should be able to accept JSON as well as reply with JSON. And when your request gets into the server, it should have certain request parameters. The first one being query, that is what your GraphQL query is, and that's mandatory. But you can have an optional operation name, which can be used for debugging purposes. So if you go back a few slides, there we go. The to-do item, that is the optional operation name. I have a variable here, and there is extensions as well. I have not used extensions, but I've just included it because it's a part of the GraphQL over HTTP spec. Talking about how GraphQL over HTTP uses HTTP verbs, unlike HTTP API, where you read information using an HTTP GET, reading here is using HTTP POST. That is the default. Mutation, subscription, query, everything happens over a POST. And the request must have the query and any variables, again, in a JSON map. However, you can use HTTP GET for querying. That needs to be explicitly enabled in many of the packages that I've seen out there. And that can be used for caching. It's useful. But if the client tries to do an a mutation over HTTP GET, immediately the execution should stop with a 405 being served. Coming to status codes, if you have no null data, a status code in the 200 range must be served. And if you have an invalid request body, or if you have GraphQL validation errors, that is errors happening before the execution, it should reply with a 400 error code. And coming to response, GraphQL as a spec doesn't talk about, which one? That is what the GraphQL spec suggests, because you are actually, because GraphQL is a very client-driven API, the client gets to choose what query they want to send to the server. So my understanding is that the client is in control there, and they want to make it safer, probably. So that's why it resorts to HTTP POST, yeah? You can have that as query string parameters. Yeah. You can put your query in your HTTP GET query parameters as well, but as I said, as a part of the spec itself, HTTP post is what is recommended. Yeah, talking about response, GraphQL doesn't have a response format as such, but JSON seems to be the most popular one. However, the response needs to have three parts or can contain only these three parts, which is data, arrays, and extensions. And GraphQL suggests that as developers and implementers, we stick to these three top-level map items. Data is the result of execution. So that is again in JSON. If an operation fails before execution, there wouldn't be any data at all, in which case there would be an errors map. And if the error was raised during the operation, you would get a null response for the data with the errors explaining what went wrong. The errors map looks like this. It's a JSON object again with it's an array of items with the message detailing what is the issue. You can pinpoint locations. You can have field errors as well. And that's the extensions. This is for additional information which the implementer can put in. Say, for example, I'm using hot chocolate in my demo. I know that hot chocolate has its own error codes which it serves through the extensions map to us. Talking about implementations of GraphQL in .NET, we have two packages, GraphQL.NET and Hot Chocolate. That's the .NET CLI command for adding hot chocolate into solution. And building the API, we start off with the object type. That's my object type. And to create a GraphQL type of my object, I inherit a class from object type of type T. I'm using the code first approach here, but there's the annotation-based and as well as schema-based approach. But I like to talk about this, which helps me slot into my head that this is an object type. And there is some mapping going on between the field names and the class names, but again, you can enhance it by further customizations like adding descriptions or adding meaningful field names, etc. That gets picked up as a part of your documentation as well. Talking about query, creating a query type follows the same method because query is also an object type or a GraphQL type at the end of the day. You create a class and have your methods in place, and these methods becomes the field on your query type. But it gets rid of the gets for you, and if you have async at the end of your method name, again, that's gotten rid for you. And if you want a query type out of this, create a class and inherit again from object type of the type query, again following the code first approach here. Moving on to gRPC, just before I move on, I haven't put mutations and subscriptions here, but I can circle back to that if we have time at the end of my talk. The third pattern of the day is gRPC HTTP API. So when I submitted the talk for NDC Copenhagen, it was an experimental project in the gRPC realm called the gRPC HTTP API. But this was a very popular community feature. The community requested it so much that it has made its way into .NET 7, and it is available in preview 4 of .NET 7 with the name gRPC JSON Transcoding. This, as a concept in the Google gRPC realm, is not new. It's been out there for some time. However, we're getting .NET support for it now, like officially, in .NET 7. Talking about gRPC, it's a modern, open source, high-performance RPC framework. And it's Google's implementation of RPC, with, which we have official support for in .NET Core 3.0 onwards. It favors contract-based API development using protofiles. So your protofiles act as your contract here. And it is designed for HTTP2, which means it makes use of all the nice HTTP2 features like request multiplexing, response streaming, etc. And messages in gRPC are transmitted in binary format using what is called protocol buffers. Protocol buffers are little messages in binary format, and that's Google's proprietary way of communication. It's not JSON. And gRPC JSON transcoding is all about how these protocol buffers maps to JSON and how we have the endpoints around the gRPC methods. So with gRPC, we have a client which communicates to the gRPC using HTTP2 post and uses protobuf, using Google protobuf for serialization and deserialization, and the response we get is protobuf as well. And all is fine in this world till we realize that there's no browser support because some of the low-lying browser APIs cannot force an HTTP2 request. We have gRPC web, but again, that needs a gRPC generated client. That's what I've put here. So when we think about a paradigm which can exist alongside gRPC, but we need the browser support, but we still don't need the generated client, that is where gRPC JSON transcoding comes in. It's an extension to ASP.NET Core, and it extends your gRPC service so that you can map your gRPC methods to HTTP endpoints. So you have a single ASP.NET Core app in which both your gRPC as well as HTTP API coexist, and clients can access this without a generated endpoint. And that is the CLI command for it. It's a NuGet package which needs to be included. And we have our gRPC service. Now a REST client or a browser can talk to it using HTTP1, using JSON, the HTTP verbs, and get back a response as well. So the idea here, according to Google, is that you can actually have a resource-oriented HTTP API in your gRPC API. When I talk about REST, I usually include a slide about how REST is not a remote procedure invocation over HTTP. But this kind of seems to me like life coming into a full circle because we have a gRPC, we have method calls over HTTP, and then we are having a resource-oriented API sitting together with it. It takes time to get used to. Now, for building the API, we start off with protocol buffers, the proto file, and see how the gRPC service functions as such, and then we can extend on top of it. There is the C# namespace, and in the C# namespace, there's a lot of code generation happening because of the tooling that we have with Visual Studio. And the service that I have in my proto file gives rise to an abstract base class called todo.todobase. And all the methods that I have in my proto file becomes virtual methods in this base abstract class. Now, I can override each of these methods in my own class and then give it a meaningful implementation. And this doesn't change when we talk about extending this gRPC service to have the HTTP API attached to it. And that's where HTTP rules come in. HTTP rule actually defines the schema of the gRPC to HTTP API mapping. So the mapping involves how we use our HTTP verbs, what endpoints are we using, and how the request messages maps to the part of the URL or query string parameters or the request body. For that, we need to have additional decorations in our proto files. The first thing is to bring in annotations proto and the HTTP proto into your project. This is a manual task of copy-paste at the moment, but I think there are plans to automate it. The second thing is we need to import this proto into our proto file. This is equivalent to bringing in C# namespaces, but from a proto perspective. And the final thing, you need to start annotating your RPC methods with the option. This actually tells the transcoding layer that there is a HTTP mapping for this particular RPC method. So this is where you start off with. So for each of the methods, you need to have this HTTP mapping, wherever if you want an HTTP mapping to be attached to that RPC method. We can then start thinking about our HTTP verbs. So in this example, I've got a get against this particular endpoint, and I've got a route parameter in place as well. So whenever it encounters something in the curly braces, that is telling the transcoding layer that for the value of this particular ID field or the parameter, it needs to go into the message request and look for a field of the same name in this instance. So the ID, it gets its value from the request here. If there are more fields in my request, that gets then bound to the URL as query string parameters. And that is my to-do item reply, which is like a carbon copy of my C# class, but this is the protobuf message. And that's what I get as a JSON response body. Now, suddenly, your gRPC method, which didn't have a browser support at all, you can now hit this endpoint using a Postman or even a browser and then get the data out. You can also have request going in as a part of request body. For example, in terms of post, you can bind the message request to the body using the star notation, which means that the entire message request is bound to the body in this instance. In fact, if you have the route parameters plus the body, then you cannot have query string parameters at all, because the star notation says that anything that's not bound to the path, bind it to the body. And if I now try and create an item, I get an output like this. You can also have custom messages or custom methods in your RPC, like sending an alert. And in that case, Google suggests using post instead of get, unless you are having alternate get. Like if you are getting a list of completed items or incomplete items, then you could relate to get, but otherwise it's all done against post again. And it needs a little method convention as well, because it expects a colon with the custom verb at the end of the URL. That is the suggested naming convention. There's also a nice mapping table of how protobuf fields and their types map to corresponding JSON types. And this is a subset of that. Again, links are in my documentation. gRPC also gives us error codes, which are quite specific, and they have corresponding HTTP mapping as well. Again, this is a subset with links to the resources in my links to the URL in my resources. Now, the error model itself, Google suggests a nice, rich error model like this with a code, a message, and detail. However, there is no support for this in the .NET realm. I have seen a couple of discussions in the GitHub issue space regarding this, and I see a target attached to the GitHub issue, so which means we could be hoping to get this in .NET 7. But there is beginnings for this in the source code of gRPC.NET. We have an RPC exception, which is the exception that you throw when you have errors, and it accepts a status struct. And it has a code field and an optional detail string. The message is not relayed to the client at all, because that is developer facing. And if I throw a new RPC exception and see what I get as a JSON response, this is what I get. It is a bit far off from what we have as the error model, but I can see the code, the message, and the details field. So I get a gist that there might be beginnings of it, but is not fully supported. But hey, I do get the corresponding HTTP mapping there. Now, how do these three API patterns compare? So it's not a full-fledged comprehensive comparison. I've just put together things that I've seen. The fundamental unit with HTTP API is resources. With GraphQL, it is query, because the client is in control. And with gRPC JSON transcoding, it is functions, because as far as gRPC JSON transcoding is, you cannot, or there is no use case. It doesn't make sense for a REST API, REST HTTP API to happen as a gRPC API. It makes sense only if you have a gRPC API and then you want to extend that to have an HTTP counterpart as well. The coupling is low in all the three paradigms. The caching, HTTP API can have seamless integration, making use of the HTTP caching. But with GraphQL, you need to resort to custom ways like persisted queries, which is built on top of HTTP GET, but that's quite an advanced topic, I think, in GraphQL. With gRPC JSON transcoding, similarly, I've seen someone play around with Redis cache and caching the responses with gRPC. But however, anything that you have in gRPC applies to gRPC transcoding as well. Similarly, if you're thinking about CORS, again, you can enable CORS with gRPC JSON transcoding. Discoverability is bad with HTTP API. There is no way to discover HTTP APIs on the fly. The hypermedia controls in REST API are supposed to be the discoverability factor, but we don't have that in HTTP API. So you need something in black and white, which is no good. GraphQL has this a nice feature of schema introspection, which is a way of the API to query itself, which means that it has given rise to some self-documenting tools. So if you think about testing tools like Banana Cake Pop or GraphQL Playground, which Michael spoke about, all these have built-in documentation kind of into that IDEs, which scans your API using the schema introspection and display that in a friendly format for you. Again, with gRPC JSON transcoding, discoverability is bad because you have a contract which you potentially need to share. And unless and until you can write down or generate something automatically for you, that's of no use. Versioning, GraphQL is regarded as a no version API, whereas with HTTP API and gRPC JSON transcoding, you need to take care of versioning. When it comes to statefulness, everything is stateless except for GraphQL subscriptions because A, that needs a persistent connection to the server, and it also needs an understanding of what clients are after, what it needs to keep in memory, etc. So there is that statefulness factor there with GraphQL. With performance, gRPC and HTTP are fine. GraphQL, I hear that it can suffer on complex queries. However, there can be multiple factors to it. It can lie in the GraphQL layer, that is where your schema is being passed and executed, or it can even travel down to the resolver layer and the layers within where the data is actually fetched from whatever your data layer is. As far as its standard is concerned, HTTP API is just best practices. So talking about it, implementing about it, and checking whether it's all good is difficult. But GraphQL and gRPC are formal specs. Maturity is maximum in HTTP API because it's widely adopted. GraphQL is early days because it's just beginning to get that boom from what I understand. gRPC JSON transcoding in .NET Realm is still early days. And talking about gRPC JSON transcoding again, there is another feature called gRPC Gateway, which can help you achieve JSON APIs, HTTP APIs in gRPC world as well. But it works in a slightly different way as compared to gRPC JSON transcoding. Learning curve is highest in GraphQL, at least that was my personal experience, whereas with HTTP API and gRPC, it's medium. Learning resources, HTTP being most mature, we have maximum resources. We are still struggling to find good resources on GraphQL, and particularly in JSON transcoding. All I have had is MS Docs as well as Google Docs, but you might find it for other languages because I think other languages are ahead of gRPC JSON transcoding support. When it comes to .NET support, HTTP API has out-of-the-box support. GraphQL has to have third-party implementations like GraphQL.NET or Chocolate. gRPC JSON transcoding is an extension and it's NuGet packages. With Visual Studio support, you have out-of-the-box templates for gRPC, and for HTTP API, and for gRPC, again, you have out-of-the-box templates, but you need to have the NuGet package and the annotations on top of it to have the gRPC JSON transcoding. With GraphQL, you need to rely on external templates. I know Hot Chocolate has a template which you can use. Azure supports hosting all the 3 API patterns with Azure Functions, Container Apps, even App Service. I know gRPC has App Service support now. And for testing, we have tools like Swagger and Postman in HTTP API. We have Banana Cake Pop, GraphQL Playground, which was the first IDE. Even Postman can help you test GraphQL. With JSON transcoding, the Open API support is yet to be investigated, but you can use Postman to test your API if needed. And that's my resources for the day. It will take you to a page with a lot of links and the GitHub repo in place. Thank you for having me today. And that's my Twitter handle again, should you wish to connect with me. I hope you have learned a thing or two.